Hi and welcome to DCO. My name is David Copete. If you're new here, I create parametric design scripts using Grasshopper. In today's video, we'll be creating a spiral pattern, and the first thing we're going to need for this is to construct a point, or we can also bring one in from Rhino. So by constructing a point here parametrically, we can change that location or route it through a point component. This way we can set it in Rhino and then change that location. But once we start with this point, then we can get into creating the whole pattern. With this, if you wanted to start at the origin, we can do that. But what I like to do for this is move it either in the X or Y direction. I'm going to be moving it here in the X direction using a slider. So I'll use unit X for the motion and then use a slider. We'll just do 15 with 2 decimal points. Next, we can array this radially, but what I like to use is series component. This way we can change that start, step, and count. And here we're going to be rotating this point. So this is going to be the geometry. The input for the location of the plane is going to be this point. Then the angle, we need to have more than one angle because by default, we're going to have 0.5 pi, or we can also change that to degrees. And as you can see, when we create a slider here, we can rotate this by 45 or by one specific angle. But what we need to do is create a step of a series of numbers that step by a specific amount. So what we'll do is, rather than using just one slider, we'll go here and do step by 15.5. Then we'll do first is bring in a slider of 360 degrees. So we'll go 0 less than 360. Now we have a slider from 0 to 360. We'll leave it at 360 here. Then we'll divide by a specific number. So we'll divide here by 15, and 360 divided by 15 is going to be 24. We'll use that for the step, and the count is how many times. So 15 times 24 equals 360. And so by doing this, now we've created more than one number, 15, starting at 0 and stepping by 24, 48, 72, 96. And now we can use all of those numbers as the input for the angle. So notice that when we change here the number, we have more numbers. We can also decrease the angle at which it rotates. Next, we need to move them just like we rotated them, but now we need to move them in stepping by 1, then 2, then 3. And so to do this, we first need to create a vector to let Grasshopper know in which direction to move each point. So to do this, we'll be creating a line segment between the start point and the end points, which are going to be these rotated points. Now with these line segments, which are the vectors, we can use a component called amplitude. Use all of those line segments individually, which are tied to each point, as the vector. And the amplitude is going to be a series also. But here, first, let's move these points using amplitude. Notice that when we use just one number, it's just going to move all of them at the same time. What we need to do is step them using a series component. So we'll copy this. We'll leave 50 in because that's how many points we have. The step we're going to change. So now we'll go here and step by 1.5. And so notice that now we have 0, 1.5, 3, 4.5, and we have 50 of them, and we have 50 points. So we're going to now plug this in. Now what we can do is take the vectors, we can hide those, and we can hide the original circles or the original point array that we created rotating them. So here with this one, notice that we can go to 0, and then we can start the spiral, which is nothing more than a step array using that same vector. So here are the things that will change once we move the sliders. This is going to be the step amount. We also can change how it spirals around. And so notice that here we only have 360, but we can also multiply 360 by a specific number. So we'll go here to 3.5. And let's actually limit the minimum to 1. And let's start at 1 here. So 360 times 1 is 360. So nothing will change using 1. And as we increase this, notice that now we're doing it times 2. Then as we move this along, we're creating this pattern that is a radial pattern, but it starts creating these points array that is based off of the spiral here. And this is actually something that you'll see in nature. So what we're going to do now is increase the number of points we have, decrease the step, and increase the array here. So starting here low and then changing it up. Now, of course, we can also change where it starts. So it's starting at the beginning and then moving it out. And what's cool about this is it's a pretty straightforward set of steps here, but it can create a lot of different patterns. So now let's take this. Just keep it here. And now let's change the points into an even amount of subdivisions. So voronoi gets a bad rap because a lot of people use it with the random points, which creates just a pretty typical pattern you see. But voronoi is nothing more than subdividing all of these points evenly by the area. So what this is going to do by plugging in voronoi 2D, using the points, now each point is subdivided evenly by creating a line segment, then where it intersects, and then it creates this pretty interesting pattern that we can change here by changing the spiral, by changing the step and the number of points, and the offset that it creates. So this is going to expand the pattern. And so this is the tutorial that I did a while back, and now I'm kind of refreshing it a little bit, showing you a few of the steps that are a little bit more simplified here. And so let's change some of this to something like that. Okay, so now that we have this pattern, voronoi is going to ask for a boundary, which by default, it'll just create whatever boundary it has here. Here is a way to extract. It doesn't even have to be this pattern. It could be any pattern. Extract a pattern using a boundary polygon. It could be a circle. It could be, whatever polygon you want. So what we'll do here is go to our initial point, create a circle. We'll change the radius. We'll go to, let's say, 50. And you might think, why don't we use this circle for the boundary on the voronoi? But what happens is it doesn't work with the circle. So here's the trick that I've found that works to be able to extract that pattern, is to first turn all of those cells into surfaces. So using boundary surfaces, we can plug all those cells in and create a surface at all of those. Then we'll create a boundary surface also for the circle. And now where those two overlap, we're going to extract the pattern. So we'll go here to intersect, physical, brep and brep, and now plug in both the pattern and the surface. Then disable the preview on everything else. And now you've basically extracted that pattern using the circle. And we can still change all of the steps that we have here. Okay. And turn those into surfaces as well. So we'll go here to boundary surface. And now these are individual surfaces that correspond with the pattern here. And so if you were trying to just create a pattern, this is perfect, a perfect tutorial for you. If you're fairly new, this is actually a pretty good one to try out. What we're going to do now is take all of these surfaces and we're going to add some color to it. So generally, I'll go to custom preview and use a color swatch to change the color here. But notice that all of these have a different area. So what I'm going to do on this part is show you how we can go to an area component, plug this in, but notice that these are all grafted. So we need to flatten the input. Then we'll just flatten the output here. Then we're going to be creating a color swatch, but this is just one color. So we'll be bringing in a gradient. Now we'll take the area, which varies for all the cells, and we'll be deconstructing domain, which all it does is it gives us the lowest and biggest numbers. So we'll plug those in here. And now we're going to look at the minimum and maximum numbers. So we'll just go from 0 to 720 or 0 to, let's go 0 less than 1000. And now we can use that as a color swatch here. So let's move this over. And since 720 is one of the bigger numbers, then we can just change the range here. Now this is just one color swatch. So like if you, let's see, if you want to change this, you just right click on it, presets, and change the color. The other thing we could do here is extrude all of these. So this is basically coloring it in 2D. But here, we're going to be taking all of the areas and be extruding it. So by default, here we could just use the area and extrude all of these in the Z direction. by the area, which means these are going to be extruded more. And we'll use the area to extrude those in the Z direction. We can also reverse the list here. And so it's going to be creating a vertical spiral like this. But if that's too drastic, we can also just divide it. So we'll divide it by 12.0. So whatever number the first one is, let's say 96 divided by 12 equals 8. So now you'll see the spiral here be able to decrease according to this number. And we can still use these extrusions as the color. So what I'm going to do is leave this one just as a 2D coloring, just in case we just want to look at that and not at this. So we can still just preview this one. Or we can also bring this down and color those. So this is probably going to be the one that I'll use for my thumbnail. But I want to show you, not just by using a division, how you can actually pick the minimum and maximum numbers. So when you have the area numbers here, what you want to do is be able to pick exactly the minimum and max, which we can use by remapping numbers. And when you remap numbers, you bring in 3 components. At least this is what I do, is remap numbers, bounds, and construct domain. This will let us pick a start, minimum, and max number, but this is how you plug these in. The domain goes into the source, this domain goes into the target, and then the numbers are going to go into the area and value. So what this component does is it will remap the numbers, but it first needs to know the minimum and maximum. It needs to know the original numbers. It needs to know what you want them to be. So here, we'll copy the slider. We'll have domain start, domain end. They have to vary. This way you'll see the change. And now, basically, it'll take the numbers 96 and the biggest and smallest number, which are going to be 37 and 1104. And the target is going to be shrinking those numbers between 2.8, or just 2, and 7. Just do 8. So now they've been remapped to these numbers. Now we can use that. So I'm going to create another train of thought here. Copy this down. Delete the numbers that were there before from the area and the division. And now the mapped numbers are going to go into the Z direction. So by disabling the preview on these two, you'll see that now here, we actually won't reverse it because we can now lower this one and raise this one. And so now the values here, let me show you why this is happening. It's because the ones on the outside are so big that I think it's going to be better if we do this. And you can still reverse the numbers here. But now we have more control in terms of what we can pick for the biggest and smallest numbers. So what you'll see here is that we have 3 different ways of viewing this. This one is going to be, let's just make this one a little bit larger here. This one's going to be where you can control the minimum and maximum. And I'm going to just hide the wire display on this to keep it clean. I'll group it and color it here with a smaller or lower opacity. And then I'll do the same thing with this one. So I'm just cleaning it up because I want to make sure that when you download this, you're able to preview these in the same way that I have it here. And that you're able to use it for whatever you want. Because with this, you can create a bunch of different patterns. You can extrude them. You can keep them in 2 dimensions. But more than anything, I just wanted to show you how to create a spiral, a few different steps so you can incorporate them in other designs. But more than anything, let's review this a little bit. We started with a base point that we then moved in the X direction. Then that was rotated to create a circular array. And then using these points as the vectors, they were then moved into a spiral using series multiplication of 360 to create this kind of larger array. And then the number is going to be how many points we'll create. From there, subdividing it evenly using voronoi, turning it into surfaces, and then extracting the overall pattern using a polygon like a circle or whatever polygon you want. Then from there, we're basically done with the pattern, and it's a matter of taking the data that we already have within the pattern, which is going to be the varying sizes of the areas, and using those as with the area component as a way to extract a pattern like this one with some color. So let's preview this one. Then the other way is to preview it as extrusions using just the area and a division of the area. And then using the areas, but being able to control it by remapping the numbers. So hopefully you learned a few new tricks. I'm going to clean this up and I'll have this available on my website for you to download. This was a refresher from an old video. So if you have any questions, let me know in the comments below. For me, the goal is to share with you more tips and tricks so you can learn how to use parametric tools. For those of you who are new or experienced, I feel like some of these tutorials can show you different workflows of how different people work within Grasshopper. So thank you very much for being here. Hopefully you learned something new and this was useful. And I hope to see you in the next video.